Okay, hello everyone. Um, uh, Today we are going to start doing some numericals on quantum mechanics because this is your first unit for BTech first semester engineering physics course. So I would start with the very basic question that is related to Heisenberg uncertainty principle. Okay, so this is the principle which states that two canonically conjugate quantities cannot be measured simultaneously beyond a certain limit, and the limit is given by Planck's constant, that is the 10 to the power minus 34 orders. So the question which was asked this year's engineering physics exam was prove the non-existence of electron inside nucleus using Heisenberg uncertainty principle. So you know that when we consider an atom, we most of the time think of it as a spherical ball, and within this atom there is a nucleus. So the typical dimension of an atom is of 1 angstrom, that is 10 to the power minus 10 meters, and the nucleus, the dimension of nucleus is of the order of 10 to the power minus 14 meters. So nucleus is about 10,000 times smaller than the atom. So atom is mostly vacuum. Okay, so we have to prove that an electron cannot reside inside the nucleus. So how are we going to prove this? So because looking at an electron is impossible, right? And even looking at an atom is quite difficult. We can do it, but there are very special procedures to do that, and special instrument to do that, to get an idea about the shape of an atom. So looking at a nucleus is beyond our reach right now. So but can we get some information about electron not being present inside the nucleus? Of course we know that electron is present inside an atom, right? So electron is present inside an atom. Electron, uh, we think of it as a probability cloud, or you can think of it as in Bohr's model, that electron is revolving around the nucleus. Of course we know that this is not the ultimate truth, but we can consider it to understand the structure of atom. So one thing is sure, that electron is inside an atom, right? So if this is an atom and this is nucleus, so we think of electron moving around the nucleus, something like this. Now we are being asked to prove that this electron is not inside this nucleus. So this is the nucleus, the center part, and we have been asked that prove that electron is not inside it. So how are we going to do this when we cannot see the electron or the nucleus? Okay. So we have some facts uh, from beta decay experiments. We know that when electron comes rushing out of an atom, its energy, maximum energy, is found to be 4 mega electron volts, that is 4 into 10 to the power 6 electron volts. So this is the kinetic energy electron that was being found in beta decay experiments. Okay, so another fact that we know, this is the first fact, that the maximum, I written it here, maximum energy of an electron inside atom is found to be 4 mega electron volt, and it has been found in beta decay experiment when electron comes out of the nucleus with a great velocity. Okay, now see, second fact that we know is the radius of nucleus is of 10 to power minus 14 meters. So this fact was known from the Rutherford's experiment. So we have two facts. Okay, now if electron is inside a nucleus and this nucleus is of the order of 10 to power minus 14 meters, so electron can be within this diameter. So the electron can be within a range of 2 into 10 to power minus 14 meters. So we can say that the uncertainty in electron's position is of the order of 2 into 10 to power minus 14 meters. Okay. So we have delta x now. So we have delta x now, uncertainty in electron's position. Okay, we also have one more fact with us, that the mass of electron is of the order of 9 into 10 to power minus 31 kg. So this was found from Thomson's experiment of charge to mass ratio, and this is a known fact, right? So we have three facts from three different experiments. Okay, now Heisenberg uncertainty principle comes into scene, which states that uncertainty in any particle's position and uncertainty in its momentum should be of the order of at least Planck's constant, and when we consider it more appropriately, it comes out to be h upon 2 pi. Okay, so delta p from this relation can be written as h upon 2 pi, and this delta x also goes down from here to here. So we have this relation with us. So putting the value of h is equal to 6.6 into 10 to the power minus 34 upon 2 pi is 6.28, and delta x is 2 into 10 to the power minus 14, right? When you put these things, you get a value of 5.275 into 10 to the power minus 21 kg meter per second. So we have delta p, that is the uncertainty in electron's momentum if it is inside the nucleus. Okay, so we have considered that electron is inside the nucleus, so its momentum has to be of this 5.275 into 10 to the power minus 21 of the order of this. Okay, so okay, so we use the formula of kinetic energy, that is kinetic energy is p square by 2m. So put these values, p is 5.275 into 10 to the power minus 21, we have to square it upon 2 into 9 into 10 to the power minus 31 from this fact, right? So you get a value of about 1.53 joules. So this is the energy that we are going to get 1.53 joules. I'm not sure. 1.53, we are missing some value here. Let me check. Okay, so this is into 10 to power minus 11 actually. So I have done some calculation here. Yeah, 10 to power minus 11. Now the kinetic energy comes out to be 1.5 into 10 to power minus 11 in joules. So if you want to convert it into electron volt, you have to divide it by 1.6 into 10 to power minus 19. So this value will now, because this is joule per electron volt, so joule and joule will get cancelled out and electron volt will go up, and it would come out to be value of 95 into 10 to power 6 electron volt actually. So you can write it as 95 mega electron volt. Now if you compare this 95 mega electron volt here with this fact that the maximum energy that electron can have inside an atom is 4 mega electron volt. So these are not supporting each other. These two facts are contrary to each other. So either this is wrong or either this is wrong. So this is wrong actually, because this electron is found to have an maximum kinetic energy of 4 mega electron volt. So we can say that for electron cannot exist inside nucleus. Why? Because it has to have a very large energy to have that, and it does not have that much energy inside an atom. Okay, thank you.